of nose. Okay, right? So here this is the nose and this is the nostril. Okay, where the air enters, right? Okay, and then you can see at the top of it. Okay, so they got the sensory cells. Okay, or we call it as a smell receptor. So on the cell receptor, they got the nerve, right? So this nerve, okay, will carry the impulse, okay, to the brain, right? And the brain will interpret. Okay, so and this is the you have to remember the component, okay, the component of the structure of the nose, okay. So this is the nostril where the air enters. So inside the air, inside the nose, okay. So they got the in the nose surface, right, inside the nostril, okay. So the surface they got the we call it as a mucus, right? Yeah, we call it as a mucus. So let's say when you smell something, let's say you smell like what your mom cooked, right? So they actually they got the chemical substance. Okay. So this chemical substance, okay, will dissolve in the mucus. Okay. So it will dissolve in the mucus. So when it dissolve into the mucus, so at the sensory cell here, so it will dissolve, okay, inside the sensory cell. So the sensory cell will produce the impulse. Okay, it will be stimulated and produce the impulse. Then it will send to the brain by the nerve. Okay, so at the surface of the inside the nose here, okay, is actually moist. Okay, so but we call it as a mucus. Okay, so as a mucus. So that's why if you're having a flu, right? So mean if you're having a flu, there's too much too much mucus. So if too much mucus, your sensory cells, okay, cannot detect, right? Cannot detect the chemical substance. Okay, so means it will not stimulate the sensory cells, okay, to produce the impulse, right? So this is the part of the nose, okay. So inside the sensory cell, so we make it bigger here. So this part, okay, so we make it bigger here. So you can see this is a sensory cell, okay. The brown one, it is a sensory cell. So at the part of this here, okay, below here, so there is a mucus, okay, on the surface of this one, okay, that I showed just now, and okay, so here they got the mucus. So when let's say you smell something, it's actually because of the chemical substance right inside the air. So it will dissolve in the mucus here. So the mucus will stimulate the sensory cells, okay, and you produce the impulse. Then the impulse will send to the nerve, but will send to the nerve, and the nerve will send it to the brain. Okay, but of course the sensory cell have to produce the impulse first, because the brain only can interpret the impulse, right? So that is the part of the nose. Okay, so for the nose, there's not so much part to remember. Okay, so actually this is a nostril. Okay, and here this is a nasal cavity. Okay, so at this part, right, this is a nasal cavity here, right? So here is a nasal cavity. This is a nostril. Okay, it's the opening of your nose. Okay, the opening of your nose is a nostril. So inside of this, okay, it's a passage here. So it's a nostril. It's a nasal cavity. So the nasal cavity, on the top of the nasal cavity, you will get the sensory smell. Okay, so this is where you detect, okay, the smell. Alright, so when you smell something, I mean inside the air, okay, the chemical substance dissolves. So it will go here. Okay, then they have got the mucus here, right? Okay, so it will dissolve inside the mucus here. So the mucus will stimulate the sensory smell to produce the impulse. Then the impulse, okay, will be sent to the brain by the nerve. Alright, so this is the part of the nose. Okay, so this one is actually more detailed. Okay, so the nose is the sensory organ of smell. Okay, so smells are chemical substance, okay, present in the air. So this one I told you just now, right? The smell is actually the why you can smell something, because there is a chemical substance, okay, that present in the air. So about 10 million sensory cells for smell are located, okay, at the roof of the nasal cavity. So if you see the diagram here, okay, here, actually it's 10 million. Alright, inside here is 10 million. So okay, so function of sensory cell or smell. So sensory cell or smell are tiny and covered with a layer of mucus. So if I let you see again the diagram. Okay, so here, see, this is sensory smell, right? So this is the mucus. So it covered by the mucus. So it will dissolve in the mucus. Okay, the chemical substance that we smell will dissolve in the mucus. Right? Right. Then chemical substance in the air will dissolve in the layer of mucus and stimulate the cells to produce the nerve impulse. Okay, and this one I just told you. Okay, so every substance, every time we smell something, mean we smell the chemical substance. Okay, and if we dissolve in the layer of mucus, then this mucus will stimulate the cells to produce the nerve impulse. So the nerve impulse are then sent to the brain to be interpreted to determine what type of smell. So let's say your mom fried the chicken, right? So the chemical substance, okay, from the when your mom fried the chicken, it will dissolve in the air. So then it will reach to you, to your nose. Okay, then when you smell, okay, the chemical substance okay come from the fried chicken, alright, will stimulate. We dissolve first in the mucus. Okay, then it will stimulate the sensory cells okay to produce the impulse. Then the impulse will be sent to the brain by the nerve. Okay, then the brain will interpret. This is the smell of the fried chicken. Like that, right? So this one is more detailed. Okay, the detection of smell. So how does the smell detected? So this is the flow. So the flow chart, right? The flow. Okay, how does the mechanism okay, of how we can smell something, right? So the first one, of course, is start from the chemical of air. Okay, chemical in the air. Okay, so the chemical in the air, like I told you just now. Okay, your mom fried the chicken. So the chemical substance, okay, come from the smell will be dissolved in the air, right? Then after that, if it goes, okay, the air will enter, okay, the nasal cavity through nostril. So the nostril is actually what? Nostril is actually the opening of your nose. Okay, that we call it as a nostril. So when you enter the nostril, you can see there is a passage, right? So the passage is called as the nasal cavity. So on the top of the nasal cavity, we have what? We have the sensory smell. Okay. So the air enters the nasal cavity through nostrils and the chemical will dissolve in the mucus layer. Okay, so this chemical will dissolve in the mucus layer. Okay, then after that, it will because you know the sensory smell is covered with the mucus, right? So when it dissolves in the mucus layer, it will stimulate. Okay, it will stimulate the sensory smell. Okay, to produce the impulse. Okay, it will stimulate. Then it will be sent to the brain. Okay, so the receptor means the nerve here. So the nerve for the sensory cell, we call it as a olfactory nerve. Okay, so it will send the message to the brain. Okay, so the nerve that send the smell, okay, that send the stimulus that come from the smell, okay, will be sent to the brain. So that nerve, okay, we call it as the olfactory nerve. Okay, so it's different. If for let's say for ears, we call it auditory nerve, right? So every part of the sense organ, they got their own name for the nerve. Okay, for smell, we call it as the olfactory nerve. So let's say for the ear, we call it auditory nerve, right? Auditory nerve. So that's the example. Okay. So every nerve in the our part of the part of organs, they got their own name. Okay. So for smell, olfactory nerve. So the brain will interpret the message as a specific smell. Okay, now we look at the tongue. Okay, so before we go further, right? So let's see the part of the tongue. Okay, for the taste, right? So let's say this is your tongue. Okay, this is your tongue. Okay, so at the in front, okay, so this one is sweet. Okay, it detect the sweet smell, sweet taste. Sorry. Okay, then this one is salty. Okay, salty. Okay, and at this part is sour. Okay, so if you want to, like take note, you can put in the, you can take write down. Okay, and at the back is a bitter. Uh, so this is the part of the tongue, right? For to taste for this for taste, right? Means if they say you if you drink something sweet, so this is the part of the tongue that will detect sweet. Okay, so we detect the taste, right? So that is the part. Okay, that is the part of tongue. Okay, that sense every taste. Okay, so now we want to see. Okay, how does the how does the how can our brain interpret the taste. Okay, so of course we have to know the part of the tongue first. So when you see the tongue, right, you can see there is a bump, right? A bump, a tiny bump. Okay, so let's say it's a tiny bump. So every bump, okay, so let's say I take one bump, okay, one bump, then I make it bigger. Okay, so you will see it's actually one bump. Okay, this is a bump. Okay, then this is called as a papilla. Okay, or papilla, right? We call it as a papilla. Okay, so papilla. Okay, so if you can see the yellow one here, right? The round one. Okay, the circle one, the yellow one. So I take one. Okay, then I make it bigger, right? So this is actually for one bump only. So I make it bigger, so it will look like this. And this one we call it as a papilla. Okay, so on the top of the papilla, okay, you can see there is a lot of round things, right? The yellow one. So I take one yellow and I make it bigger. Okay, so this is called as the taste bud. This one, the tiny one, the yellow one, we call it as the taste bud, right? And this one we call it as a papilla. Okay, this one we call it papilla. And on the top of the papilla, they got the taste bud. So they got many taste buds here. Okay. Then you can see, okay, this is when I make it bigger. So this is the paw. Okay, this is the paw where when you eat something, right? Okay, so of course you have a saliva. So the food will dissolve in the saliva. So this saliva we go to the paw here. Right? We go to the paw here. So means the paw is actually the opening. Okay, the pot is the opening. Then you see the pink one. Okay, so this one is the supporting cell. Okay, this is the supporting cell. And the yellow one here, this is the important one. Then because of this one, okay, because of this, right, you can taste, okay, you can taste your food, right? This is called as the taste receptor. Right, this is called as the taste receptor. So when they mention the receptor, what does it mean? The receptor means it detects the taste and it changes the taste to the impulse, right? So the function of the receptor doesn't matter whether it's for eyes, for ears, for nose, right, for skin. So when they mention about the receptor, you have to remember the receptor is the one that it produce the impulse. Okay, so it's a very important part, right? So this is called a supporting cell and this is a taste receptor. So then you can see the taste receptor here, right? You can see here, it connected to the brain. Okay, so it connected to the brain here. So if we go to brain, then the brain will interpret what is the taste that we sense. Okay, so that is actually the roughly about how does the tongue works. Okay, so we go further. Okay, so the structure of the tongue. So the tongue is the sensory organ of taste. So I think all of you already know this one. So there are tiny nodules, okay, or bump that we know as a papillae on the surface of the tongue. Okay. Okay, and then the surface of the papilla is covered by hundreds of taste buds. Yeah, so if you see the diagram before, uh, so this is the tiny bump here, right? Or the tiny bump here, we call it as the papilla. So on the top of the papilla, they got the taste bud here. So this taste bud, we make it bigger, right? Yeah, the yellow one is called as the taste bud. Okay, this one is called as the nodule. A nodule here is called as the papilla. Okay, so I hope you remember the structure because after this we will do some quiz. Okay. So the tongue is the sensory organ of taste. So there are tiny nodules, nose and papilla on the surface of the tongue. So the surface of the tongue is covered by hundreds of taste buds. Remember the yellow one, right? Okay, and then each taste bud contains 10 to 50 taste receptors. So it's already 100 of taste bud, but each taste bud they got 10 to 50. So it's almost like 1,000, right? 100,000, okay, of the taste bud, okay, on our tongue. So the taste receptor can detect, okay, it can detect 5 types of basic taste, which are sweet, salty, sour, bitter, and umami. Yeah, I forgot to tell you. Okay, umami. Where is the part that tastes the umami? Okay, so umami is actually on the middle here. So what? How does the umami taste? So it's like the taste of the meat. Okay, or MSG. MSG also tastes like umami. Okay, so you have to remember the part of the tongue. Okay, so this one is much detailed, but you don't need to know. Okay, that detail. Okay, just like for your info. Okay, you just need to know the one that I just told you just now for papilla and also the taste bud, right? The smell is the taste receptor, okay, and also the supporting cell. Only that one. Okay. So this is the different part. So already they give you the part, okay, of tongue, okay, that are more sensitive to specific taste. Okay. So area of the tongue are sensitive to all 5 tastes. Okay. So right, is sensitive to all 5 tastes. So, however, different areas of the tongue have different sensitivity towards specific taste. So, for example, the area in front is more sensitive to sweet taste, okay, whereas the sides are more sensitive to sour and salty taste. So, let's say if you eat a medicine, you're taking a pill, right, for the medicine. So you put usually we put at the back, right? Right. So next time maybe you can put here because if you put at the back, of course you will detect the bitter taste, right? Of course, usually the pills, right? It still it tastes bitter. So you put it in front here, so it will make it less bitter. Okay, because every part of the tongue tastes a different taste, right? So the area of a tongue is more sensitive to bitter taste. So the area of center, however, more sensitive to umami. So umami, yes, right at this part. So actually, what is the taste of umami? So umami is classified as a basic taste because there are taste receptors that can only detect umami taste. Okay, so this is the same as other basic tastes such as sweet, salty, sour, and bitter. The umami taste is related to delicious taste such as the taste of meat in soup. okay, and taste of fermented food such as cheese, mushroom, or monosodium glutamate, okay, MSG. The one that we put like a salt, right, in the cooking. Usually, we use Ajinomoto. If you heard, right, there's a brand called Ajinomoto, right? So that is actually the part of MSG. Okay, so next, a function of the taste bud. Okay, so when the food is chewed, okay, part of the chemical substance in the food dissolve in the saliva. So how can we sense the taste, right? So of course, the first one inside in your mouth, right? They got the saliva. So when you eat something, okay, so I give you an example. So let's say you eat mango, right? So when you eat mango, okay, you chew the mango. Okay. So when you chew the mango, it will dissolve, right, in your saliva. So when it dissolves in your saliva, of course, on the top of your tongue, they got the papilla, right, and also the taste bud. So it will. So I show you again the diagram. Okay, it's much easier if I use the diagram here. They say if you don't understand anything, you can just put in the chat. I I also log in using my handphone. Okay, you can just log in. Okay. All right. So I just explain again. So when you eat something, you eat mango, right? So when you chew the mango, okay, and then it dissolve in the saliva, then the saliva will go at the paw here. Okay. Then you can see here they got what? Okay, they got what? They got the taste receptor here. So it will dissolve. Okay, it will dissolve here. It will dissolve and go here. Then it will go to the taste receptor, right? So now the taste receptor will what? It will stimulate. And after it stimulate, it will produce what? Here, the yellow one. After it stimulate, it produce what? It produce impulse. So everything okay that we need when we want to send something to the brain, it must be in the impulse form. Okay. Okay. Then this dissolved chemical substance will diffuse into the taste bud through their pores. So remember the pore that I mentioned just now. So this dissolved chemical substance, okay, when it dissolve into the saliva, so it already is called as the chemical substance. So this chemical substance will diffuse into the taste bud through their pores and stimulate the taste receptor to produce the nerve impulse. Okay, so like I said just now, every food that you eat, they have the chemical substance. Okay, so this chemical substance dissolve in your saliva. When you chew, it will dissolve in your saliva. The saliva then will dissolve. Okay, will diffuse in the taste buds. You see the yellow one, the round one. So it will dissolve in that. Okay, through the pulse. Okay, and it will stimulate the taste receptor to produce the nerve impulse. So these nerve impulse are then sent to the brain to be interpreted as sweet, salty, sour, bitter, and umami, or combination of the basic taste. Alright, so some of you may be wondering why can we feel, let's say you eat spicy things, right? So you see, how can we detect that it's a spicy taste? Because in our part of tongue, there is no spicy part, right? There is no part that sends the spicy sense. So it's because inside the spicy food, they got the chemical substance. So this chemical substance make your tongue, okay, should kind of feel hurt, okay, but your brain interpret it as a spicy sense, okay. So actually, the chemical substance inside there is a chemical substance inside the spicy food. So this chemical substance can make your tongue feel like it's hurt. But your brain, okay, interpret, okay, that hurt is actually the spicy, spicy food, okay. Okay, detection of taste. So this is the mechanism. Okay, how does our tongue works? So the first, the chemical in the food release, okay, by chewing. So you have to chew first the food. So inside the food, I tell you they got the chemical, okay, substance. Then after that, the chemical dissolved by saliva. Okay, it dissolved by saliva. Then it will detect, okay, by the taste receptor that they will stimulate, sorry, it will stimulate the taste receptor. Then the taste receptor will produce impulse first, then it will send message to the brain. Right, so I hope you are clear. Then the brain will interpret lah, okay, what type of taste that you uh, okay. So we go, wait for a moment. Okay, so this is the last one for skin. Okay, then after that we go to the another part. Okay, then after I finish with the skin, we do some piece, then we stop. Okay, so skin. So this is the part of skin. So at the top of your skin, okay, here, the top layer, you see the pink one. Okay, so this one we call it as the epidermis. The layer is called the epidermis. Okay, epidermis. Okay, so this is the epidermis part. Okay, so this is called as the epidermis part. Okay, so you see, this is the epidermis part. So here, from here to here, okay, so at this part, okay, at this part, this is called as dermis. Okay, this is called as dermis. Okay, and at the bottom here is a fat layer. Okay, it's a fat layer. Okay, so this is epidermis, this is dermis, and the last one is the fat layer. Okay, so why skin is actually the part of our sensory organ? So this is the answer. Because at the below part of our skin, okay, they got 5 receptors. So remember what is the receptor? Receptor is the one that we detect the stimuli, and it will change it to impulse and send to the brain. Okay, so this is why we say skin are also part of the sensory organ, because under skin you got 5 receptors. So let's see the first one. Okay, so you can see the layer, the nearest receptor. Okay, the nearest receptor, okay, is what is a pain receptor, right? You can see this is the nearest to the layer of the skin, right? So this is your skin. So the first receptor that you will see, you will find is actually a pain receptor. So this one is the most important one. If you put it below, if you put it far away from your skin, so it's hard for the receptor to sense the pain. Okay, so if you put it nearest, so every time let's say you touch something sharp, okay, so of course your skin will automatically detect. If you put it lower, right, far away from your skin, it will take some time, or maybe it will take more, like, like the stimulus must be so strong. So then it can be sensed. So, but at that time, maybe you already got hurt by it. Okay. So that's why they put the pain receptor the first. Okay. The nearest one is the pain receptor. Okay. And the second one is actually the heat, cold, and also the touch receptor. Okay. They put it almost the same level. Okay. So heat, of course, lah, to detect the heat receptor. Sorry, the heat stimuli. Touch receptor to detect the touch stimuli, and the cold receptor here to detect the cold cold stimuli. Okay, so you have to remember the shape of the receptor, because every receptor they get their own shape. Okay, So like this one, you can see it's like a curl, right? Curly there. Okay, for the touch receptor, it's like a curly. Okay, inside of it. And this one is like a tree, right? So you have to remember the shape of the receptor. So how about the pressure receptor? So actually it is the below one, the below part. So this is the pressure receptor. Then you have to see this, the shape also is different, right? So you need to know, okay, the shape of the each receptor. They got the different one. So this is the pressure receptor, of course, to detect the pressure. Okay, and you can see all the receptor is connected to what? Is connected to nerve. See? So this nerve will do what? Will transfer the impulse to the brain, right? So this is the part of skin. Okay, so the skin is the largest sensory organ in the human body, of course, right? We already all of our body covered with skin. Okay, so it's the largest sensory organ. Okay, then the human skin is made up, okay, of a thin outer layer known as epidermis. So on the top is epidermis. So second layer is dermis. So at dermis, after dermis is what? Is a fat layer, right? So the structure of human skin, there are three layers: epidermis, dermis, and also fat layer, or we call it as hypodermis. Okay, so epidermis. So epidermis is the outer layer of the skin. Okay, it's divided into three layers. So outer layers is made up of a dead cells. Okay, so tough and water resistant. So your skin is water resistant and also protects the cells under it. So it prevents the entry of germs into our body. So this is the first layer of our self-defense, okay, system. So dermis is inner layer of skin. So blood vessel, glands, and also the receptor are found. So the glands, what glands? Sweat glands. Sorry, sweat glands. So every time that you have, you play soccer, let's say, right? So there will be sweat, right, coming up from your skin. So that is the glands actually produce it. So they got the receptor, touch receptor, pain receptor, heat receptor, cold receptor, pressure receptor. So there are five receptors. Okay, then this is layer. Okay, it's a layer directly below the dermis and serve to connect the skin to the fibrous tissue of the bone and muscle. Okay, so this is a fat layer. Okay, so we see the skin. Skin has five types of receptor at different positions to detect the stimuli. So when the receptor in the skin is stimulated, okay, nerve impulse are produced and sent through the nervous system to the brain to be interpreted and produce an response. Okay, what kind of response? So this is the receptor. We already see it. So pain receptor, I said just now, nearest to the epidermis, nerve endings. Okay, touch receptor sensitive to slight pressure, found more abundantly in certain parts. Okay, let's say on your fingertips, right? So it's more sensitive there. Okay, the touch receptor is more sensitive at your fingertips because if you touch something, it's easy for you to feel it. Alright. For the pressure is sensitive to pressure, so located the furthest. So the nearest is pain receptor, the furthest is pressure receptor. So stimulate when any object press hard against the skin. Okay, so this one, of course, you know, sensitive to cool, sensitive to heat. So sensitivity of the skin on different parts of body towards stimuli. So what is the factor that influence, okay, the sensitivity of the skin? Okay, so the first factor is the number of receptor, and the second one is the thickness of the skin epidermis. So if that, so you, let's say on your fingertips, right? So on your fingertips, it's easy for you to detect. Let's say you hold or you touch something sharp. So you are easy for the fingertips to feel it, right? So because at the fingertips there are a large number of receptors, especially the pain receptor, and at the fingertip the thickness of the skin epidermis is quite uh thin. Okay, it's quite thin. So for example, the tip of finger is very sensitive to touch. Okay, because of the tip of finger, there is a large number of touch receptor and the epidermis is thick. Okay, so the tongue, nose, and lips are also very sensitive to touch. So the elbow, okay, the sole of the foot, and the back of body are less sensitive to touch. Okay, all right. So I stop until here first. Okay, we go to the quiz. Okay, so we do some quiz. Okay, I will give you a link and I want you to join. Okay. For the attendance, don't worry, it's automatic recorded. Okay, so I will later receive an email and they will tell me when you left, when you enter, or if you do something else. Okay, let's say you don't watch what I teach. Okay, you're doing something else. Okay, Google something else. They will tell me. So I will decide if they say you're doing something else, then I will put your attendance zero. Okay, although you are in the class. Okay, so please, okay, if when I teach, you have to listen. So please join the quiz now. So whether to see you are understand what I teach just now or you don't understand. So it's supposed to be like 21 here, right? How many of you actually? Anyone know how many of you actually? 35. So means 14 didn't come today. Okay, thank you, Sichuan. Okay, others, please join. Only 4. Where's others? I give until like 2 minutes. Please join the 7. Where's and 14 more? Hmm. Teacher, I think my line got some problem. I can join the quiz, okay? Others? Later I will send you the link, alright? And you have to answer it. Okay, then you screenshot to me what is your mark. 14, it should be 21. Minus me 3. Minus 1, another 4. Alright, that's wrong. Okay, so already 2 minutes. Okay, so I will just take attendance for this 14 students. And also for reaching. Only 10 questions. Very good. Which one? Lizzie, Angel, very good. Oh, already got wrong. It's okay. Okay, after this we discuss, okay, the answer. Then after that we stop. Okay, Chinchat already finished. Oh, I said you got all right. Very good. Okay, very good. 'Kay, I give you like 2 more minutes, okay, for you to finish the quiz, then we discuss, right? Eight 20 we stop. Okay, 1 minute more. Okay, it's quite good. Okay. Okay. I stop here, right? Okay, so we discuss. Okay, very good. Okay, Isaac, Wong Kai Jung, Angel. Okay. Okay, so let's discuss, okay, the answer. Then we stop. Okay. What is the sensory cells, okay, for the smell located? Where is the sensory cell? So remember, it's on the top of what? On the top of the nasal cavity. So remember, I said the opening, right? And the passage, we call it the nasal cavity. So on the top of it is a sensory smell. Okay. Which organ which organ is the sensory of taste? So you taste using your what? Of course, your tongue. Your nose is actually for what? Actually for smell, okay, not for taste. Okay, so diagram 4 shows a section through part of the human head, okay, containing a sensory organ. Which of the part that birth A, B, C, D is a sensory cell? So the answer is B. Okay, C is no. A also is actually the nerve. Okay, so B here is here, right? It's here. Okay, when a person suffers from flu, the food will not be delicious. This is because of, remember I said, if you are having a flu, okay, I mean there is excess of mucus, okay, there is a lot of mucus. So when it's a lot of mucus, okay, the mucus is too thick, right? So when the mucus is too thick, it covered your sensory smell. Okay, when it covered the sensory smell and the mucus is too thick, so every chemical substance that dissolves, it cannot reach the sensory cell because the mucus is too thick. Okay, so the abundance of mucus quantity in the nasal opening, okay, prevent the chemicals from stimulating the receptor cell. So this one I just told you just now. Okay, very good for the 9th student. I mean, you are hearing what I said. Okay, which following is not a type of receptor? So the answer is hot. It's not hot, it's heat. Heat receptor, not hot receptor. Okay. Yeah, they got the pressure receptor. Remember the furthest one? Okay, yeah, this is skin, right? Ears is actually for sound. Okay, detect sound. Why does blind people use their fingertips? Because they have thin epidermal layer and many receptors. Okay, very good. If you have a thick epidermal layer, means your sensory will not be sensitive. Okay. Okay, cells senses all the following except okay, depth perception. Okay, so touch, pain, cold, of course they can sense because there are 5 receptors there. Okay, heat receptor, cold receptor, touch receptor, pain receptor, and pressure receptor. Okay, so the last one, diagram shows a girl is crying because she stepped on a thorn. So what is the sensory organ that involved? Of course, skin, right? Not eyes. Okay. If eyes, you only can see. Okay, or if you already see, of course you will step on it, right? So this is of course the sense. The pain is actually skin. Okay, so I think I will stop now. So later, so next week, okay, we continue with the topic. Okay, so thank you everyone. Okay, bye. Bye. Welcome.